Hey there, fourth graders. I hope your online learning is going well at home. Thank you so much for participating. Super excited about our class meeting today. Maybe it already happened or maybe it's going to happen depending on when you've watched this video. But today we're going to be talking about multiples of fractions. So before we get to that, I have a joke for you. Actually, I've got two jokes. So the first joke is, why was the math book sad? Because it had a lot of problems. That's a good one, right? That's funny. It had a lot of problems because it's a math book. And then the other joke I had, these are both sad jokes. Why was the obtuse triangle sad? Because it's never right. Because it's obtuse, right? Triangle, right? Okay. So when we're thinking about multiples of fractions, the best way to do it is actually to put it on a number line. So I'm going to draw my number line right here. And then let's say, I'm actually going to get a little bit thicker marker so you guys can see that better. Oh yeah, now we're talking. So let's think about how we would do, 3 times 1/5. So if you remember, this multiplication symbol is the same thing as groups of. So this means that I have 3 groups of 1/5. So to start my number line, I always want to put a 0, and then I'm going to put a 1 just because I'm dealing with numbers that are smaller than 1. However, this number line can be as big as you needed it to, so we could extend that out as far as we wanted, and actually technically in the other direction too, but you'll get to that later. So what I'm going to do now is I'm going to mark my number line into fifths because I'm dealing with 1/5. You're always going to want to take this fraction and use that to know how you're going to break up your numbers that are less than 1. They're called intervals, or the chunks that you're dealing with. So here is 1, 2, 3, 4, 5. So 1/5. 2/5, 3/5, 4/5, and then we have 1 whole here, which we know is the same thing as 5/5. So if I hope you guys can see that. I'll write bigger on the next one. So if I'm going to do 3 groups of 1/5, I'm going to start here at 0, and I'm just going to jump 1/5 each time. So 1/5, 1/5, 1/5. Here I've got 3 jumps, and each jump is 1/5. So that means that 3 groups of 1/5 equals 3/5, because that's where I ended up on my number line. Let's do one more that has 1 as the numerator, and then we'll get into a few more complex problems. So let's say we had 5 times 1/7. Yeah, you can see that. So here's my big giant number line. I'm going to mark 0 over here, and then 1 over here. I'm also just going to put a 7/7 under here, just to remind myself that 1 is the same thing as 7/7. Then I'm going to mark my intervals: 1/7, 2/7, 3/7, 4/7, 5/7, 6/7, and then 1 whole, or 7/7. And I'll make this a 1 so you can tell it's a 1 and not just a line. So if I'm going to do 5 groups of 1/7, I'm going to start here at 0, and I'm going to count. Each hop is going to be 1/7, and I'm going to do 5 different hops. So here we have 1 hop, 2 hops, 3 hops, 4 hops, 5 hops. And actually, technically, I should have labeled these beforehand. 1/7, 2/7, 3/7. I said it, but I didn't label it. And yep, you caught it. That should be 7ths. So here I have 1 hop, 2 hop, 3 hop, 4 hop, 5 hops. So I ended up at 5/7 on my number line. So that means 5 times 1/7 is the same thing as 5/7. So when there's a 1 in the numerator, these are super easy because you're just counting by 1/7 each time. It gets a little bit trickier when you're counting by more than 1 as the numerator at a time. So let's try one of those. Let's say, for example, let's do 3 times 2/4. So here I have 3 as my, how many times I will be hopping, because I have 3 groups of 2/4. So each hop will be worth 2/4. I'm going to do 3 hops of 2/4 each. So let's put my big giant number line. And this one, I'm pretty sure that this one, just with my estimate, that it's going to be larger than 1 because I know that 4/4 equals 1 whole. So if I have 3 groups of 2/4, that's going to actually be more than 4/4, which is 1 whole. So I'm just going to do 1 here, 2 here, and a 3 there, and I'll put a 0. I'll put a 0 right here. So my next step is to cut my number line into fourths. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, making sure that my 4s are always lining up with my whole numbers. So this would be 1/4, then I have 2/4, 3/4, and then 1 whole is 4/4, 5/4, 6/4, 7/4, 8/4, 9/4, 10/4, 11/4, and 12/4. So I'm going to start here at 0, and let's remember what my number says here. 3 groups of 2/4. That means I'm going to do 3 hops, and each hop I'm going to be moving 2/4. So I'm going to start here at 0, and I'm going to move my first hop. Notice, some of you will be tempted to hop to the 1/4. Don't do that. You need to hop to the 2/4 because I have groups of 2/4. That's where students, when they make mistakes in this lesson, that's where they do it, is they want to just do 1/4 always and forever. But you have to look. This means I'm hopping by 2/4 because I have 3 groups of 2/4. All right, back to the action. So I have 1 hop of 2/4, another hop of 2/4, which got me to 4/4, which is 1 whole, and then another hop. So I take a look at that, and I ended up, when I did 3 hops, and each hop of 2/4, that actually got me to 6/4. And we've already learned how to regroup fractions, and I know 6/4 is equal to 1 and 2/4, which is actually equal to 1 and 1/2. If you get all the way to 1 and 1/2, that's great, but as long as you get the 6/4 for today, I'm fine with that. Now let's think of some other ways we can make sure that that's the right answer. Remember that the multiplication symbol means groups of, so I could rewrite 3 times 2/4 as the same thing as 2/4 plus 2/4 plus 2/4. And then 2 plus 2 is 4, 4 plus 2 is 6/4. So I got the same answer when I wrote it as repeated addition. Okay, let's do another one. Let's do another one with a number line, and then I will show you the algorithm, or the way you can multiply it without drawing a picture. So let's have 5 times 2/7. So I'm going to draw a big number line here, and I'm going to do the same thing. I'm just going to do it into 3, 1 and 2 and 3. And you just are going to have to, just as you get a feel for fractions, you'll kind of know how long or how small to do your number line, but 3 is going to work for us. So I need to cut each of these up into 7 pieces. So 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, and then 7. And then I'm going to take time to label these. 1/7. It's going to get crowded. 2/7, 3/7, 4/7, 5/7, 6/7, and then 1 whole is the same thing as 7/7, 8/7, 9/7, 10/7, 11/7, 12/7, 13/7, and then 2 wholes is the same thing as 14/7. Let's keep going. 15/7, 16/7, 17/7, 18/7, 19/7, 20/7, and then 3 wholes would be equal to 21/7. In a perfect world, this would be a little bit more stretched out and neater, but you work with what you got. So I'm going to do 5 hops, and each hop is going to be worth 2/7, not 1/7, not 3/7, 2/7. Let's see what that looks like. So I'm going to start here at 0. 2/7, there's 1 hop. 2/7, there's another hop. 2/7, there's another hop. 2/7, there's another hop. And then 2/7, there is another hop. So when I hopped 1, 2, 3, 4, 5 times, I ended up at this number right here, which is 10/7. If you're making a number line at home, make sure that these hash marks, these lines on your number line, match up very closely with the fraction underneath. So 5 times 2/7 equals 10/7. And I could, I could wax off that, turn into a mixed number, which would be 1 3/7, which is what I ended up with right here. So that's if you want to do a number line, that's how you would do it. If you want to just list out the multiples, you could do that. You could do 2/7, 4/7, 6/7, 8/7, 10/7. I'm just listing out the multiples. That's basically the same thing as hopping, just without constructing the whole number line. That works too to get to that. One more way you can do it, and this is the algorithm way. Now, if you notice, our answer was 2/7. Our denominator is going to stay the same because we're not changing the size of the pieces. Whenever you change the size of the pieces, the denominator has to change, but we're not doing it in this case, so the denominator does not change. Or when you change the size of the pieces, the denominator does change, but we're not. We're counting by the same amount each time, so the denominator of 7 stays the same. So if you're going to multiply a whole number times a fraction, what you do is you take this whole number and you multiply it by the numerator. So in this case, that would be 5 times 2 equals 10, and the denominator is 7. That 7 stays the same. So take the whole number, multiply it times the numerator, and then you get your fraction greater than 1 of 10/7, which we could we could regroup into 1 3/7. So let's try another one. Let's try 3 times 5/6. So same thing. I'm going to take the whole number and I multiply it times the numerator to equal 15/6. 3 times 5 is 15, and then I keep the 6 for my denominator. All right, let's try one last one. Let's try 7 times, what's a good fraction? I think 5/9 is a good fraction. We'll do a little bit bigger one. So 7 groups of 5/9. I'm going to take 7 times 5, which equals 35. And then my denominator stays 9ths. And I could regroup that into, what would that be? 4 and, let's see, 9 goes into 35 3 times, so 3 and 3/9. 3 and 8/9. And this works because I'm basically adding 5/9 together 7 times. So you just take the whole number, multiply it times the numerator. So thank you so much for watching. Good luck on your math skills today, and I appreciate all your hard work. Bye-bye.